All right, let's dive right in. Today we're talking about how AI in medicine is officially past the what if stage. This isn't science fiction anymore. We're talking about real, revolutionary treatments that are happening right now, and they are changing everything.
For the longest time, the big story with AI in healthcare was all about prediction. Crunching insane amounts of data to see problems coming. And don't get me wrong, that's amazing stuff. But the story has taken a huge dramatic turn because AI isn't just predicting what's going to happen anymore.
That's right. It is fixing it. We have walked right into a new era where AI is an active part of the treatment, making procedures better, making doctors superhuman, and, get this, even creating brand new biology from scratch. We're going to break this down into 3 acts so you can see just how this revolution is playing out.
Okay, Act 1. Let's look at AI as the ultimate co-pilot in the operating room. We're talking about a tool that brings a level of precision that's just, well, it's beyond human.
50%. I want you to think about that number. That's how many men over the age of 60 are dealing with a condition called BPH. It's super common, but the treatments, well, they've always come with some pretty serious risks. And that's exactly the problem a new AI-powered system is designed to solve.
So how does this thing, the HYDOS system, actually pull this off? It's really a beautiful 4-step dance. First, an AI creates a personalized 3D map of the patient's anatomy. Then, advanced imaging gives the surgeon this crystal clear, real-time view. Now, step 3 is the real game changer. Instead of heat, it uses a heat-free water jet to remove tissue. And finally, a robotic arm carries out that perfect plan with a level of accuracy a human hand just can't match.
And the difference here is it's night and day. See, traditional surgery relies on heat, lasers, cauterizing, and that always carries a risk of damaging surrounding tissue. Hydros just takes heat completely out of the equation. It's replaced by this incredibly precise AI-guided water jet, which dramatically lowers those risks and, crucially, preserves function. It is a massive, massive leap forward for patients.
So, for our second act, AI steps out of the physical world and becomes this cognitive powerhouse. It's an analyst that can spot patterns in data that are literally invisible to the human eye. And this is where things get really wild. Let's take a common heart condition, AFib. The standard treatment is pretty good, It has about a 70% success rate. But look what happens when you bring AI into the picture. When an AI guides the procedure, pointing out these tiny, hidden trouble spots in the heart, that success rate jumps all the way to nearly 90%. That's not just a little better, that's a whole new ballgame.
So you might be asking, how in the world does an AI get that smart? Well, one of the core ideas is something called normative learning. Imagine this. You show an AI thousands and thousands of scans of perfectly healthy brains. You don't tell it what's wrong. You just teach it, in unbelievable detail, what perfectly normal looks like. It gets so good at recognizing normal that it can instantly flag anything at all, that deviates from that baseline, no matter how tiny.
And this whole normative learning thing is already a game changer for brain scans. The AI can find all sorts of problems without ever having been specifically trained to look for them. It's also giving doctors totally new ways to measure brain health, things like RQI and CACI. Right now, it's already matching the skill of expert human radiologists, and the crazy part is, it's just getting started. This is going to totally revolutionize early detection.
And that brings us to our final act. And honestly, this is the part that feels like it was ripped straight out of a movie. This is where AI stops being an assistant or an analyst and becomes a creator. It's designing brand new biology from the ground up. Okay, I just want you to stare at this number for a second. 60,000 times. For decades, scientists have been trying to engineer enzymes. It's slow, incredibly difficult work. But recently, an enzyme that was designed completely by an AI works 60,000 times faster than any version humans had ever managed to build before. That's not an improvement, that's a paradigm shift. So, how did they do it? It was this brilliant 2 AI team-up. The first AI, called RF diffusion, was like the dreamer, the architect. It just generated millions of possible blueprints for protein structures. Then, a second AI, Placer, came in like the master engineer. It took those blueprints and fine-tuned every single atom to make sure the final enzyme would actually work. This isn't just about discovering biology anymore. We're building it. So let's step back. What does this all mean for us, really? We've seen AI as a robot with perfect precision, as an analyst with superhuman perception, and now as a biological creator. This isn't just about medicine getting a few new toys. What this means is that the fundamental limits of what we thought was possible in healing are just evaporating right in front of us.
So, what's next? You've got the precise robot, the all seeing analyst, and the creative biologist. Which one of these do you think is going to hit the mainstream first and have the biggest immediate impact on our lives? It's a pretty incredible question to even be asking, and the amazing thing is, the answer is unfolding as we speak. Thanks for tuning in.